Hello, this is the first and final part of the chapter 4.8, and we will talk here how to use our system of difference equation. Okay, and before we discuss that for our signals, we can write it down as the systems of difference equation. So bunch of term multiplying by the signal at the step from step is equal k to the k plus n. And it's kind of convenient, but also very, very cumbersome. It's a very long equations with a lot of numbers. And if you're dealing with a computer, you want to have something a little bit more universal. And the modern way to write down the difference equations is usually we select a new variable at step k plus 1 and express it in terms of the variable on the previous steps k times some kind of matrix. And we basically say that it's a recursive system. Recursive, it means because we're using step xk to find the k plus value on the k plus 1 step. But let's see how we can transform from the linear difference equation to the first order different equation. And again, the first order because we're going to the k plus 1 index here. Okay, let's take our linear difference equation. You probably recognize it from the previous two chapters. We still work with the same equations, just trying to get comfortable with it. And let's try to write it down as the first order system. Basically, we need some variable x, and we need to define it and the step k plus 1 using the step k. Okay, what will be our variable xk? Well, let's use our signal y at step k, k plus 1, and k plus 2. Basically, everything until the very final step, k plus 3. We separate here last state and all the previous steps before it. Okay, so what would be then x on step k plus 1? That's pretty straightforward. Take our y's and add one more step to the index, which give us y k plus 1, k plus 2, and k plus 3. We're basically shifting our y's. Okay, so now the idea is to basically express our k plus 3 through all previous indexes of k using our linear difference equation. So we basically keep yk plus 3 on the left side, and all the rest of the terms will go to the right side. Obviously, the sign will change. Okay, so now let's go back to our xk plus 1, and will write down our k plus 3 in terms of this 3 other terms. And we also, so since we have now 3 components, yk, k plus 1, and k plus 2, we'll write it down as the sum of 3 vectors. One at the position yk, another is k plus 1, and finally the third at the k plus 2 position. And our first component only have yk plus 1, so we'll keep the yk plus 1, and the other 2 terms should be equal 0. The yk plus 2, again the same, 2 other components will be 0. Finally, our k plus 3 has 3 components, minus 6yk plus 5yk plus 1 and 2k plus 2. Okay, so now instead of 1 vector, we have a sum of 3. And we can now write this down as actually a linear combination. It's probably not surprisingly, we've done it like 100 times in this course, write down our vectors as a linear combination. So we basically took all our coefficients in front of yk plus 1, and yk plus 2, and combined them in the single matrix. And of course, we multiply by the vector of yk with k plus 1 and yk plus 2. And What's an interesting fact? That's exactly the same vector as vector xk, which we started. So look what we started. We start with the xk plus 1 and end up with some kind of matrix time vector xk. And this is exactly what our first order equation supposed to look. So all we need to do is summarize our matrix, tell that its name is A, and move on. And in general, we can use this approach to pretty much any matrix. So our linear difference equation can be written as a first order equation where our matrix xk will contain all components up to the very one before the last one, yk plus n minus 1. And our matrix A will have a bottom line, the coefficients A's, and all the lines above would have zeros except of the ones and appropriate column relevant to the position of our coefficient. Okay, so now we can go between the first order system and linear difference equation. So I'd like you to go to the end of the chapter and try to practice to going from one to another. So, and again, it takes a little bit of practice, but it's really interesting that this recursive approach is very common to computer science. So please spend some time on it. It will be a useful investment in your future.